So far, in our journey through rational function land, we've been taking rational functions and we've been turning them into graphs. What we now need to learn is how to take a graph of a rational function and turn it into the actual equation. So let's say you were given this graph. We have a vertical asymptote right here at x equals -1, a vertical asymptote at x equals 2, and we have a horizontal asymptote at y equals 1. We also have x-intercepts at 1 and 3, and we have a y-intercept at 1. How will we go about building a rational function? Well, let's start by looking at the zeros. If we start by looking at the zeros here and here, we know that when you plug in 1 and you plug in 3 into our rational function, the fraction has to come out to be 0. When you plug in 1 and when you plug in 3, the fraction has to come out to be 0. The way you make a fraction 0 is you make the numerator 0. This tells us that x minus 1 must be a factor of the numerator, and x minus 3 must also be a factor of the numerator. So at this point we know this. We know that the numerator has to have this in it, because when you plug in 1 and 3, the function must be 0. The function must come out to be 0. Now what about the vertical asymptotes? What do the vertical asymptotes tell you? Well, we know that that's going to relate to the denominator, and we know that the function isn't defined at -1 and it is not defined at 2, meaning you cannot plug in -1 or 2 into the denominator. That tells us that x plus 1 and x minus 2 must be factors of the denominator. The next part we need to look at is the direction the arrows are pointing as they approach the vertical asymptotes. Down here at 2, we notice that they're both going down. That tells us that we have an even multiplicity, meaning the power of the term in the denominator that results in that asymptote must be even. So we know that this power must be even. Now, we know that this is going in the same direction. We also know there must be an even multiplicity here. So that tells us that this term must have an even power. So why am I picking 2? I'm picking 2 because it's the lowest power that's even. Could I have picked 4 or 8 for each of them? Sure, I'm picking 2 to keep it as small as possible. So far we verified we're okay with the x-intercepts, we're okay with the vertical asymptotes. Let's look at the horizontal asymptote now. Let's look at the horizontal asymptote. If we look at the horizontal asymptote, that tells us that the degree of p of x must equal the degree of q of x. That's the only way we can end up with a horizontal asymptote that is not the x-axis. It also tells us that the leading coefficients after you multiply out the numerator and the denominator must be the same. The leading coefficients must be the same. So, how do you go about doing this? So what do we need to modify? Well, at this point, the degree of the numerator is equal to 2, because this would be a quadratic if you multiplied it out, and the degree of the denominator is 4. The degrees are not the same, so right now this does not have a horizontal asymptote at 1. It has a horizontal asymptote at 0. So how do we move it up without affecting the overall, the vertical asymptotes or the x-intercepts? Well, we need to add something to the numerator that increases the power. We need to add something to the numerator that increases the overall degree of the numerator to 4. We want this degree to be 4. This is where it gets a little challenging because we also have to take into consideration the point right here. It's crossing at 1, meaning the y-intercept is 1. So we need to fulfill these things. When x is 0, we need y to be 1, and we need the degree of the numerator to be equal to the degree of the denominator. we need to be careful about this because we can't create other zeros. We can't create more zeros. So what we're actually going to do is put something in that definitely doesn't have a 0 and helps us increase the power of the numerator by 2. If we put x squared plus some constant there, as long as c is greater than 0, x squared plus c never crosses the x-axis, so it doesn't add a 0 into this graph. We also know, what's nice about this, we also know that when we plug x equaling 0 into this equation, it should come out to be 1. So that will allow us to solve for c. Let's give that a try. What I mean by that, if x is 0 here, that means you have -1 times -3 times c over 1 squared times -2 squared. And we want that to equal 1. We want it to equal 1 because that's the horizontal asymptote. So this means that 3c over 4 has to be 1. So this tells us that c has to equal 4/3. What does that mean? We now know that c is 4/3, so we now have x minus 1, x plus 3, x squared plus 4/3 all over x plus 1 squared, x minus 2 squared. This is our function. These two tell us that we have vertical asymptotes at x equals -1 and x equals 2. This tells us we have an x-intercept at 1, 0, and this tells us we have an x-intercept at -3, 0. This doesn't add any zeros because if you tried to solve this for 0, you would end up with x squared is equal to -4/3. Anything squared, can it equal a negative number? X is imaginary. So it means that it doesn't cross. So just taking stock again, we have our vertical asymptotes, we have our zeros, and then also, because these are even multiplicity, we're going in the same direction. All of these facts match this graph right here. The one last thing we need to check is, does our function cross at 1? Does our function cross at 1? The y-axis at 1? Well, when x is 0 on this function right here, we end up with -1 times 3 times 4/3 all over 1 squared times -2 squared. What's that going to be? Oh, look, there's a mistake. I am human. I made a copy error up here. This should actually be x minus 3. So this right here should be 3, 0, which actually matches our graph. Sorry about that. So what does that mean? This is actually -3. So you end up with 3 times 4/3 all over 4, which is 4 over 4, which is 1. So the key things to remember here: denominator, vertical asymptotes. Numerator, zeros. The hardest part by far is finding this term, and we'll definitely talk about that tomorrow. I want you to be able to build as much of the function as you can, so please focus on this part of the denominator and this part of the numerator. And it's really okay at this point if you don't quite understand why or how we ended up with x squared plus 4/3.